Okay, girls, we're going to do chapter 12.6, measures of a spread. So measures of a spread. In analyzing a set of scores, it is helpful to see not only how the scores tend to cluster, those are the measures of Santa that we already cover, um, median, mean, and mode, or how the middle of the set looks, but also how they spread or scatter. So that's what we're going to be covering today, how the data spread scatter that also give us information. Let's look, two classes may have the same average mark, but the spread of a score may differ considerably. So let's look at this one. I have an example of a year 6 blue, and I have scores here of a test. Let's say the 1, 2, 3, 4, 5. And what can we see here? So I have one student that got 1, 4 students that got 2, 10 students that got 3, 4 students that had 4, and then 1 student that had 5. You can find the average of this one. You can have your frequency table, and you can create what is the average of this one. But the average of this one, I did it in Excel here, and the average is 3. Okay, so the average for this class is 3, and we can see it here that the average is 3. Yeah, you will see it in a minute why I'm saying that the average is 3. But we can see here that very few students got low scores and very few students had high scores. Most of the students were in the middle. Agree? So we have this behavior of 6 blue. Now, if we look into the next class, another class, 6 purple, this class, the average is also 3, but the distribution is very different. I had the same amount of students that got 1, 2, 3, 4, and 5. So like there is no concentration of one student of a mark that was most popular. I have the same amount of students that got 1, 2, 3, 4, 5. So it's a very different class, and the behavior of this data is very different to the behavior of this data, even though both have the same average. So that's what we mean that it's important to analyze how the data is spread or scattered to be able to understand better both data. Wonderful. So the range of a set of score is the difference between the highest and the lowest score. So if we look at these examples again, so my highest score is 5 in here in blue, and my lowest is 1. Therefore, my range is going to be 4. 5, take away 1, that's my range. And in my 6th class purple, the same thing. My highest score is 5, my lowest is 1, then my range is 4. So even though I was going up. So even though thus the range is the same, this range will be helpful if the range differs a lot from one data to another. In this case, doesn't make a much difference to explain the difference between these two data, but it's a measure of a spread, okay? And you have some examples to calculate the range of a set of data. Okay, wonderful. The skewness. In reality, not many data sets have a symmetrical distribution. They are said to be skewed. Oh, symmetrical. Sorry, girls. I'm jumping from one slide to the other. So what is symmetrical distribution? So symmetrical distribution values of mean, median, and mode are very close. And any of these measures could be used to describe the central value of the data. So a symmetrical distribution basically is, I need to change here. Basically means that you can divide your graph around the mean or the average, and you get asymmetrical. So if I fold this one over here, we see that both sides I have a very symmetrical. I will have the same data. If I fold it along this line that I just dotted here, I will have the same data. That means that there is a symmetrical distribution. And both of these data, even though they're very different, are symmetrical, okay? Fantastic. And when that happens, the mean, the median, and the mode are very close, okay? And these measures could be used to describe the central value. Now, in reality, not many data sets have a symmetrical distribution. They are called skewed. Okay, so let's look at this example here that I have. So here I have amount of people in thousands, and here have the income, and horizontally have the income. And we can see here that the data, if I want to see, is like this. So more people has less income, and less people have more income, which is true in most societies. The mean is here, and we can see that this data is skewed. Agree? It's skewed to the left. I have more people that has less income. Okay, so very different to the previous examples that I had. When a greater number of scores are distributed at the lower end of the distribution, the data are said to be called positive skew. So like the example before, when I have the lower, like most of the data is concentrated to the left, this is called positive skew. So when it has like this shape like this, okay? Similarly, when most scores are distributed to the upper end, so to the right here, these data are called negatively skewed, as shown here. This graph is not very good, but it does explain things, so that's why I wanted to copy. It's not very clear, but I hope you can see it. So if I have a positive skewed data, like the one that I have here, usually the most common value will be a little bit to the left, the median will be here, and the mean will be around here. When it's symmetrical distribution, all the three ones will be around the center. And when it's negative skew, the mean will be over here, the median here, and the mode more towards that crest. Wonderful. We'll do this example in the next video.